All right, what do we got left assessment-wise? We got a chapter test, and we got semester final. Chapter test, semester finals. And then we're done. Yeah, that's the way I'm going to because they're all going to be in standard form. Okay, I've been told the field. Well, you told me this, right, yesterday? Yeah. Okay, and Miss Allen did confirm that. Then she said, "Wait a minute, it looks like it might snow on Tuesday." So then she said, "Well, maybe Friday." I don't know. Whatever it is, we will have the test on that. Even if we have a snow day, which will be an e-learning day, and it happened to be one of those or whatever, I'm still going to teach that class that day. So what you see in front of you will absolutely happen even with a snow day. Meaning that the test is going to be on that Monday, and then we'll do something, and then, like I said, I think I'm going to do dilations, and then we'll jump right into the semester final reviews. And then semester final, they started publishing the schedule today, which was, I just got an email on it. Not that it makes that much difference. You probably won't remember anyway between now and then, but it says, let's see, what does it say? Miss Newbern, where are you, Miss Newbern? Zoom, 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 zoom. 2, 4, 6, 7, 1, 3, 5. So like Monday would be period 2, period 4. Tuesday 6, 7. Wednesday 1, 3. Thursday 5. What do you got for 5th period? You're gonna have a final for that. Okay. All right. Homework. Oh, I didn't collect homework, did I? Back to questions on the homework.
Oh, can I go to my locker?
Sure.
No, my homework is it.
Obviously, most of this was graphing, so on the same.
All of it's graphing. Except for the last 6.
I gave the regular geometry students the same homework. They're like, "What? 7 through 24 all?"
Oh, that was like.
It was just the intercepts. Every single one of these, with the exception of, was it 11?
Yeah, it was not. Yeah.
11 and 12 were the only ones where it was not a multiple of the constant. So you could do the whole thing in your head.
So why are we solving systems by element? So do we just graph the system that we get?
Are we what?
Do we just graph the system that we get by solving it? The both of them?
No, you're going to use eliminations.
Right. Do we graph that system that we get?
No, just to solve. It says, then draw graphs of the equations. I'll change the instructions to, I just want the solution.
Oh, why are we doing this now then?
Good question. Well, I mean, the real answer is that this particular chapter proves everything that we did in Algebra 1, so that technically we've proven everything that you've learned in math up to this point. So, I mean, one of the things we did. Now, you might argue, well, it doesn't do system of inequality. Well, it follows the same rules.
We didn't prove the quadratic formula, did we?
I actually did that last year.
You did?
I did.
Proved it?
Yeah.
Really?
Yeah. I'll show you the class. You may or may not remember it. Do you remember doing complete the square?
Oh, yeah.
Do you remember talking about complete the square?
To be honest, I already knew how to do it, so I didn't.
Nobody remembers how to do it. You know, it goes out your ears really quickly. But anyway, the class right after complete the square is the quadratic formula, and the quadratic form comes from complete the square. All right, no questions? All right, homework for tonight, which is basically those system of equations.
And
5 through 6. And the only reason I didn't include 5 through 6 because they're vertical and horizontal lines. That's the part that we didn't do.
Well, at least we get some easy
So,
ones.
Mr. Chartier, on the quiz, I thought I did the vectors right.
You did the graph right.
Vector.
You did.
I followed my notes.
You did the only thing you did wrong was the when you squared -4, you put -16. It's +16. So the procedure was entirely every procedure is right. You just silly mistake.
Would have been right if you were using complex mode.
Oh, and Jack, what you said yesterday was not true. You did
Yes,
something
that's how it
weird
works
on
in
your
my-
calculator.
That's how it works in my calculator if I put it in complex mode.
You gotta have to show me that because mine doesn't do that.
I don't have it with me, but I mean,
Here's mine. You got the same calculator. I think I still left it in complex mode too.
yeah, it is.
All right, here we go. Did I hand the things out already? Yes. Okay, good. So we'll do this as quickly or as slowly as you can take it.
Oh, okay.
Oh
I see
yeah,
what
because you
we're
don't put parentheses. Gem
doing.
dash.
Okay.
I was like, I was thinking because complex numbers are a combination of real numbers and imaginary numbers. I was like, well, maybe there's no. Yeah, that's always the case. If the negative doesn't have parentheses, the answer is always negative for squaring.
But not in real mode.
Not in what?
Not in real mode.
Oh no, in real mode too. It follows gem dash.
No, I promise you.
Okay, what are we gonna bet?
I'll bet you.
It's
I already know I'm right here.
If I
so.
get it right, then I don't have to bring donuts.
You
Well,
never
we've
know.
done this
Like
before and it didn't work last
Well,
time.
then I just won't have Anna railing on me all day. Yeah, deny it, Anna.
Are you willing to bet 2 points off your semester final?
2 points off the final?
Yeah.
What? Okay.
Well, if you win, then you get an extra 2 points. I gotta make it hurt.
Okay.
You sure you want to make this bet?
Mhm.
All right.
Pretty sure he's right.
I swear, I've done this before on my calculator.
2 points aren't gonna hurt you, so.
You didn't have to say yes to that. I just realized you
I
lost 2
swear.
points.
Well, it makes no sense.
It's because of GEMDAS. You
Well,
do
then my
squaring
calculator
before you
does-
do
If
subtraction.
my calculator does something, why did you take the asymptote of your program Donkey Kong?
Remember I told you I had to jailbreak? That's the jailbreak program.
Oh, genius.
All right. We better get back to this or we'll run out of time. So linear equations, where do we leave off? These were equations that make lines. That means x is to the first power, not to the second power. I'm doing quadratics in algebra 1. And then yesterday we spent the whole day on standard form, where this is slope-intercept form. And remember, standard form is the form ax plus by equals c. Okay. There's an example right there. In fact, is that no? That's not that line. 2x plus 1. That's that line. And then the last part of the class we did was on slope-intercept form. That's the form of y equals mx plus b, where m is the slope and b is the y-intercept. We proved that. Cool. That's where we left off. Homework was mostly graphing last night. We graphed. I showed you how to graph with the intercept form. And then the very, 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 very last thing we did, which was we graphed with the slope-intercept form. I briefly talked about table values, and did I show you on the calculator where the table pane was? Was that this class I did it in? I never showed you that? You have your calculators with you?
I do.
I have yours.
If you have not realized it yet, your calculator has the table of pain in it, right? Go ahead and hit y equals and type in, I don't care, it could be quadratic or linear, just type in some function. I don't know, maybe put this, 2x plus 3. You remember doing the table of pain, right?
Yeah.
So the table of pain is you did this thing, what numbers did you pick?
0 or -1.
-1, 0, 1, and then you threw 1 in for x. 2 times 1 is,
2.
plus 3 is,
5.
and then you did this for each one. It's called table of pain because it takes forever. Your calculator does it for you. So you got this typed in?
Yeah.
Everybody? All right. Hit second. Look at the very top. Guess what button you're going to press? Look, hit second, and then it's blue. Guess what button you're about to press?
Graph.
No.
You're about to press trace.
Table.
Oh, okay.
And-
Someplace the graph.
And it makes the table of pain. Let me show her. And then, by the way, hit the arrow keys. It doesn't stop. You can scroll up and scroll down. You can also, there's another button up there called table set. So the table automatically by default goes up and down by ones. But if you wanted your table to go up by 0.5, you could literally say on table set, hey, make the X values go up or down. And you could say, where do you want your table to start at? I think the table by default starts at 0, but if you want it to start at negative 4,000, you could tell it, hey, start at negative 4,000 rather than scrolling down. Okay. That wasn't this class. I know I showed that to somebody. So what's left to do? Well, let's see. We did all of these lines right here, graphing by intercepts. And this is how we ended the class yesterday. What did we leave off? Which lines haven't we graphed? Okay. And we also haven't graphed that line right there. And why can't we graph this one by graphing the intercepts? Well, it has one intercept, right? It's not a vertical or horizontal line, but it only has one intercept. So we got to talk about that one, and this one. And then we'll talk about system equations, and that's it. It's really not 2 classes or 2 days worth of class material, about a day and a half. All right, so let's talk about this one right here. Notice it's a diagonal line, so it's not vertical or horizontal. It only has one intercept. Technically it has 2, but the intercepts are exactly the same. They both go to the X and the Y at 0. All right. In standard form, it would literally look like this, by the way. Right? We throw in 0 for X, Y equals 0. We throw the 0 in for Y. Well, we get negative X equals 0, but if you multiply both sides by negative 1, you get X equals 0. So, yeah, great. If you plot the intercept points, you get one dot right here in the center at 0, 0. You don't know where to draw the line.
Well, you can go up 0 and over 0.
And you could.
That's true.
It's true, but it really isn't. 0 is not the slope, by the way. If we turn this, however, into slope-intercept form, move the X to the other side, we would get.
That's what happens when you graph.
We move the X to the other side, we would get
X.
the whole thing.
Y equals X.
Negative 1.
Where are we getting a 1 from?
Y equals X.
We get Y equals X, right? If we just add X to both sides. Now, if you wanted to put plus 0, because we like it in the form of slope-intercept, well, the intercept is 0, the slope is 1, so instead of going up 0 over 0, up 1 over 1. Okay, so I mean that's a possibility. Nobody writes it like that, but you could, I guess. They just write Y equals X. Become very familiar with this one, Y equals X. You'll learn later. It doesn't look like it, but this is actually a 45-degree angle right here, because it goes up 1 over 1, up 1 over 1. So it's kind of like splitting this quadrant. Very good. I'm thinking I got the wrong graph here because this should go right through here. This is not X equals. Why is that messed up? Well, that's weird. This is close to Y equals X, but it should actually go through 5, 5. Ugh. Why didn't I notice this before I taught this? Bothersome. Okay, so what's left to do now? We're going to talk about horizontal and vertical lines. So horizontal and vertical lines. In box 1, write this down. A horizontal line has a slope of
0.
y0.
Yeah.
y0. WHY 0.
Well, that's something because if you go, because you can go up 1 or down 1, you'd still be at 0 over 0. But you'd be at 0 over 0.
Yeah, but the line doesn't go up 1.
Right. So if you're going up 1, you'd have to go down 1. So you
Yeah,
would
but
just
the line doesn't go up
You
1.
would just be going like this. So you would just be 0. You would be 0 there.
I mean, I get kind of what you're saying, but you would never go up 1 because the line doesn't go up 1.
Oh, okay. How about this? If you use the slope formula,
Oh.
then if you have the x's on the bottom, the
Yeah.
x's are
Yes.
yeah, the x's on the bottom and the y's on the top. The y's are always the same, so you get that minus that,
Which
so
gives
it's
you,
0. So it's 0 over whatever the x is.
and on the bottom, you would actually get a number, right? And that's how I'll do it as well, too. You would get a run no matter what 2 points you pick there. I don't know, 5 and 4. 5 minus 4 is 1. The problem is on the top, the y values would never change. You get 3 minus 3, right? And well, in this case, 4 minus 4. And that would give you a 0. And you can have a 0 on the top, and 0 divided by anything other than 0 is 0. Okay. How do you write a horizontal line in slope-intercept form? First off, what is slope-intercept form?
Y equals mx plus b.
What's the slope of a horizontal line?
0.
So throw 0 in for m, and what do you get?
Y equals 0.
Y equals not 0, y equals,
0.
keep talking,
Plus
Couldn't that be easily written as,
Y equals 0 plus B.
which could be even more easily written as?
Y equals B.
Yeah, okay. Now, I have no idea why mathematicians weren't satisfied with this, but they weren't. Like, we don't like you, B. We're going to write the letter K. Don't ask me why. There's no good reason. But instead of saying y equals b is the form of a horizontal line, we like to say y equals k. Yeah, it's b. K is the b value. This is what causes high school students big issues, and why they find math confusing is because we do something idiot like this. It's b. Why couldn't it be b? But no, they wanted to write k. The reason why they write k is considered the constant. German constant k.
Are we stealing from the German?
Yeah, because there's just a lot of smart German mathematicians way back when.
What?
Okay. And you hopefully you remember me saying this a bunch of times last year, that all horizontal lines are the form of y equals k. Okay, we good? Box 1, horizontal lines. Well, box 2 is vertical lines. Vertical lines. All right, you're on again, Jack.
Slope of undefined.
Why is it undefined?
Because you get, since the x's are on the bottom, then the x's are 0 on the bottom. So,
And
So you get
and so you get whatever the change in y is over 0,
yeah, and so why is that a problem?
because you can't have anything over 0.
Can't divide anything by 0, so we say undefined. Okay. Well, if the slope is undefined, I can't even write it in slope-intercept form. I mean, I can't write y equals undefined thing times x plus b because, well, you can't put the symbol in an equation, undefined. The equation could equal undefined, but it can't be inside of an equation. That makes sense. So we got to think more about, well, what does it mean if you're a vertical line? If you're a vertical line and you pick any 2 points, I don't know if that's 2 or not, but if it was, that would be 2, comma 2, right? And this point, I don't know what it is, but let's say it's still, I'm sorry, negative 2, 2. And this point right here would be negative 2, negative 2. And this point right here would be what? Negative 2, comma negative 3. And this point right here would be a negative 2, comma positive 3. Guess what number never changes? The x value, which is how we decide to define a vertical line. And a vertical line is defined as just the, since the x value never changed, we say it's defined as x equals k. Once again, high school students have a problem. Remember this, because you really want to say for a vertical line, it's y equals k, because you're thinking of the y-axis and it goes up and down. But horizontal lines are defined as y equals k, and vertical lines are defined as x equals k, because that's the value that doesn't change. On a horizontal line, the thing that never changes is the y value. On a vertical line, the thing that, I was eating cashews to lunch, and for some reason, I don't think I swallowed. That was weird. Okay. And then for vertical lines, the thing that doesn't change is the x value, which is a paradox, right? But you just got to, that's why so many times last year I said, write this down, put it on your resource card so you don't forget, so you get to a test and you screw it up. Yes, we will insult your intelligence. This is more of an Algebra 1 thing. We will ask you to graph and then write the equations of each one. So we'll do it really quick. McKinley, horizontal, vertical, top one.
It goes across the x-axis.
Horizontal or vertical?
Oh, sorry, it's a vertical, not horizontal.
It is a horizontal line. So all you have to do is look at the, it says horizontal line. All you have to go to the y value 2, put a dot, and then draw a horizontal line. And
Yeah.
horizontal, vertical. It is vertical. So we find where x is equal to -1, put a dot and draw a vertical line. Jack?
Vertical.
Find a dot on -3, draw a vertical line. Allie, last one.
horizontal.
Actually, this is the,
That's just the x-axis.
yeah, it's just the x-axis, right? All right, I know you probably can't see this, Anna, but this red line right here, horizontal or vertical?
Horizontal.
Can you see the squares? 1, 2, 3. So
One.
what's the equation for a horizontal line when it goes through 3?
Y equals 3.
Y equals 3. Okay. We're back to Ben.
Yeah.
Blue line right here. You can't see it. It's on your paper. 1, 2, 3, 4, 5. X equals 5. Oh, I didn't do them in order. I did both the horizontal ones first.
-2.
Right. Yeah. Okay. So this one is -2. Ben's was, all right. I really didn't do them in order. The y-axis is actually x equals 0. It's a paradox. The y-axis is x equals 0. The x-axis is y equals 0. It's a paradox. I should pay more attention, put them in order. Okay. Questions. This is question 5 and 6, by the way. These right here. Seems like we're done. We're going to jump right into system equations, knock it out real quick. Remember, we're talking about 2 lines. There are 3 things that can happen when you have 2 lines. You remember doing this last year. Either the lines intersect. How many points can they intersect at if they do, in fact, intersect?
One.
Remember, this is in 3D, by the way, right? If they're skew, they don't intersect. They're also not parallel. This is parallel. This was skew. But if they intersect, the only time, we're talking lines, not curves. Curves can intersect in plenty of places. But lines can only intersect at 1, none if they're parallel or skew. We're not doing 3 dimensions in sophomore year height or in geometry. Pre-calculus, we will do 3 dimensions. I don't think we ever, I guess we do that in pre-calculus. Then if the lines are literally the same, we say infinite solutions. Okay. There are 3 methods to solve a system of equations. Well, one's called graphing, either by hand or with your graphing calculator. The second one is called substitution. Pretty good technique. You're going to use substitution when one of the equation is in standard form and one of them is in slope-intercept form. It's the quickest way to do it. The third one, which is everyone tonight for homework, both equations are going to be in standard form. When they're both in standard form, don't waste your time. I'm going to grab my graphing calculator because I know it'll give you the right answer. Because you got to put them in a slope-intercept form to plug them into your calculator. So you got to do a whole bunch of work before you even can plug it into your calculator, and you can screw that work up. It's way easier to do elimination. All right, if both equations are in y equals mx plus b, well, you can still use elimination in that. But if you do have a graphing calculator, I would use the graphing calculator. Okay. These were the steps. Step number 1, you stack the equation. Now, make sure your x's line up with your y, x's with the x's, and the y's line up with your y's. They're in standard form. Step number 2, you got to determine whether you add or subtract. Do you remember whether we add or subtract, how we figured that one out? So, yeah, but how do we know if we add or subtract?
By the negative.
Is this one we're going to add or subtract, do you think? Why add, not subtract? Yes. So what you're looking for is you're matching either the x's or the y's, their coefficients. If they're the same number, then you will add or subtract. If they're not the same number, we got to do an extra step. But if they are the same number, you would like one to be negative and one to be positive, and when that's the case, you add. When they're both the same, either both positive or both negative, then you subtract. So this one is an add one. So if we add these, you can see the x's go away. We get a negative 7y, we get a 14, then we get y is equal to negative 2. So we solve for that variable, negative 2. Then we take this answer. This is half of your answer, by the way. You just found the y value where the lines intersect. You take this answer, you go back to the original 2, and you pick one. Which one do we want? First or second one? Somebody. Why the second one, not the first one?
Because that's the one that
Has fewer negatives, fewer chance to make a mistake. You can choose either one. It doesn't make a difference. You will get the same answer. We're going to choose one. I'm going to choose that one. Plus, I can see that this is a negative, and now I'll have everything be positive. The answer might be negative, but I'll at least get everything positive. You can choose either one. It doesn't make a difference. I'll choose this one. I'm choosing it because I like positive numbers. And then we solve that. So x equals -1. You take these two answers in yellow or brown, whatever color that is, put them together. You can still screw this up because depending upon which one you solve for first, right? Remember, we write ordered pairs as x, y, not y, x. I've seen it plenty of times where the kid makes it this far and they just write the numbers in the wrong order. It goes x, y. And you're done. Cool. One more time. Are we adding or subtracting?
Subtraction.
Okay. Now, is everybody paying attention? Because subtraction is the one that will kick your butt. Why?
Because you
Because you
turn
turn
everything
everything
into a
into a
Very good. You got to turn everything the opposite. So notice I got the same thing. I got to subtract. So as soon as you decide that I got to subtract, I need to change all of these signs. This 2 now becomes,
-2.
this 6 becomes, and that 8 becomes,
Positive.
and that negative becomes a positive as well too. So negative, positive, positive. I'm just changing, I'm writing the opposite of every sign. Okay. And the reason why, if you remember why this is necessary, because subtraction is the same as adding the opposite of everything. So we change the opposite of everything. And then it's just like the previous one. We add, solve for one variable. There will only be one variable left. That's why it's called elimination, because we eliminated the x's. And we take our answer, we plug it into either equation. Right, I'll probably go with the top one. Everything's positive. You could go with either one. It doesn't matter. And just simply solve that equation for x. Write your answer as x comma y, and you're done. 2, 2. 2, 2 is the point that makes both of these equations true. 2, 2 is the only point that both lines have in common. Remember, all points make a line true. Like if you throw these values 2, 2 into each equation, and the left side equals the right side. 4 plus 6 equals 10. -4 plus 12 equals 8. It makes both equations true. That's the only point that does that. Okay. Tonight for homework, I think they already have everything stacked for you, like on a test. Sometimes they'll be stacked for you. Be careful on number 28 on the homework. And the reason why on 28, because for some reason, they flip-flop things around on you. One isn't, it's the only one that's in standard form, one of the equations, and the other equation is in slope-intercept form. It's the only one. I'm not sure why they only did it once, but they did do it once. All right, so I stacked both equations, and we got a big problem. What's the problem?
They're not the same.
Nothing matches.
Just multiply them by 2 or 3 or whatever. you
Which
do.
one?
Oh,
The
the bottom
bottom
one.
one by
By,
3.
3.
and what's your goal here when you do that multiplication?
To get something that
And it's a twofold goal. One, we want to get the numbers the same, but we would really like if one's positive and the other one's negative. So choose your scalar multiplication that does that. In this case, yeah, multiply it by 3. Okay. You can match the x's or the y's. It doesn't really make a difference. And just be careful. You got to multiply everything. A lot of times you forget to multiply the constant by whatever your scalar is. And that's going to give you 21, -15, and what, 51? Now we add. And the rest is just the same. Okay. I'm not sure why I wrote that, but I did. Why did I choose that one to write the 0? I'm not sure. So we get x equals 1. Now we go back to any one of the 3 equations. You're like, what 3 equations? Well, we got this first top one. The second one, well, I mean, PowerPoint, I already changed the numbers, but we actually could go way back to the start and throw 1 in for the x value here if we wanted to. It's your choice, since I already messed up and changed all the numbers. I'm going to use one of these 2 up here. So I chose that one because the numbers are smaller, but I could have, and a better choice would have been what this was originally, because the numbers are really small there. All right, so we throw 1 in for x. Another mistake is simply just, you made this far, you just throw it in the wrong spot. And then we go to town. Add 2. Divide by 15. And then finally, notice this is the one that always causes problems. You get so excited you made it this far, you're, oh look, -2, 1, and you wrote the answer backwards. Got to go x, y, not y, x. So 1, -2, 1, -2. Feeling confident?
No.
No? Yes? All right, what are we doing?
Times the top one by 3.
Top one by 3, and that would give me the y's would cancel. All right, so top one by 3. I'm going to skip this, move on to another one. Oh, by the way, look how ugly those answers are. That can happen. How about this one?
Multiply
Which one, top or bottom?
by 5.
Bottom by 5. How about this one? Oh, that's too easy. How about this one?
Multiply by 3.
Top or bottom? Bottom. And then the last one,
There's actually 4 more on our sheet.
there are. So which one do I want to skip to?
Box 7.
Yeah,
Bigger
box 7.
numbers.
Okay. No, box 7 is still simple. It's just
Big
bottom
numbers.
times -8. Well, that's a big number. It's box 8. All right, McKinley, what are we doing on this one?
You have to turn both of the, you have to multiply both equations by,
Top by,
top by 3.
okay. Which one are you matching, X's or Y's?
I'm matching Y's,
Okay, so top one by 3, I like that. It gives me a 6Y.
and the bottom by 2.
You can do that, but then you would have exactly the same. And then you'd have to
Oh,
subtract and
negative.
change all the signs. So let's do one of them by a negative, and that way you don't have to. But everything you said there was perfect. It's just that then you would see that you'd have to subtract. So I'm gonna do top by 3, bottom by -2, and it doesn't matter which one was negative, top or bottom. And then we've matched the y's, and then it turns into addition. And that's it. We got this? Okay. If you wanted to use your calculator to check this, what would you have to do? If you wanted to use your calculator to check your answer, what would you have to do?
You would have to set y and x as their values, and then
What do you mean?
you have to say this stored in x or this stored in y, and then you have to
Nope.
enter, and then it'll put 1 if it's right.
What would you have to do? You could do it that way, but let's think of it a different way.
You could graph it.
We could graph it. But in order to graph it, both of these equations, we'd have to, what? Can you type this in your calculator, both of these?
No, you have to put in y equals mx.
We got to throw in the y equals mx. That's absolutely why we want to use elimination and not graphing. There is a third way of doing it, and it's using a system of matrices that you will learn in Algebra 2. And that's when you look at your calculator, you see a matrix button. There's a whole branch of mathematics called linear algebra that uses matrices to do really cool things. And one of them is this right here. There is a button on your calculator that once you learn it in Algebra 2 that does this, all of this. You simply hit that button and you type in 963,864. You hit this magic button and it spits out the answer. And you'll learn about it in Algebra 2. You do matrices. Did I get the homework or no? No.
Do we have to draw?
No, I said you didn't have to.
Oh,
I said just give me the answer. Have you ruined my calculator?
No, I found the weirdest things.
It's not like you drew snowflakes on it, Ben. What? Yeah, I got it. Well, fine, you gave that. Did multiple functions.
Well, yeah, I mean, that's not one line, but I don't know why that works. I don't know why it's just a line. And
It
why does
isn't. If
stop?
we zoom in, you can probably see that it isn't a line.
But why does it stop?
Oh, good. Better question. Better question. I don't have an answer to that. I've never actually done that.
And the red line, but I don't understand why does it stop. What happens?
Well, take this home with you.
I know what I do.
Look it over again.
I know.
Yeah. But I mean, take it home with you.
I don't
Look it over
have
again,
bread.
and then tomorrow during essay, we'll fix it. Okay? You'll get them all fired up right now. Oh, sorry. Were you here for class or were you gone? You're very quiet. I know that seems weird, but
The minute something has a B on one of the grades in the house, it's a good house. It's like basically Seattle. Get rid of it all. Vampire. I'm going to become a vampire with this. The cheese boy.
yeah.
I'll put this on my face and become vampire.
Can't tell you off the top of my head.
I got so mad. Connor. So mad.
The funky, that's the food funky.
Yeah. I love
What is that? Don't tell me that's your character.
So I got moved.
No! Boy!
You didn't even do it good. I'll have you write that.
Do it well. You don't do things good, you do them well.
No, he didn't do it good.
That doesn't make any sense.
I didn't say she
You don't do things good, you do things well.
Yeah, he didn't do it well.
You know, Mr. Babb.
Yeah, but good means the opposite of bad, right? Like moral, like good and bad, right? You don't do things good, you do things well.
No. You can learn to ride your t-shirt back. It's not that hard. One of the hours classes. It's just an ability extra. Ability is extra large size. It works great.
I didn't know that.
I put that in my mom's line.
Yeah, math worksheet.
What?
Done the math.
What about it? Yes. Yes. Oh, and I screwed overhanded it. I did not get
Alright, good afternoon. Great. Here's Ricardo Milo.
my name.
Amelia. Connor, you're in the wrong seat once again. please. I swear I want to talk.
End of discussion.
He's
Maddie
being
left.
quiet.
You have had months. Nathan isn't sitting next to me. Oh, he does fun.
Nathan.
Madison, John,
Here.
Ava, Devin, Jake is gone.
Yeah, left early. Research.
Aiden,
You don't do that from. You don't do that.
water bottle for Caitlin. You just gotta butter me up and then you'll get whatever you want, right? It's not that hard. Manny, Natalie, Laura, Antonio, Turner,
Or what?
Let down your language.
Yeah.
All right, guys, what's somebody responsible tell me this stat on homework by raising your hand. The rest of you can dip your mouth. John first.
Okay, so let's see. Latin tomorrow. Yes, I have homework to do tomorrow. And then we got like 1 to 4 all pay 423. Yes.
Thank you. Then we have history.
History study for test. And do that
English.
English is the paragraphs and the essays isn't homework.
Yes, but actually no.
It's due tomorrow. June 11th. But the paragraphs are. Nail polish or context? I know, but the paragraph is supposed to be tomorrow.
Hey, oh, Laura, I'm a grade when she can stop here.
I bet almost big whole thing.
You haven't even done any of it. Oh, I want to be my
Up here. Thank you.
Isn't that a J spot? No. Nail polish or nail.
Alright, guys, it looks like you have homework to do. So your voices are off now. Thank you.
Okay.
When?
That's not funny. That's gonna be an email home. Wait, what? And then I'll start writing detentions for real. If you would like me to. Seems a little excessive for people talking back, but it happens every day, guys. You know what you could say right now? I'm sorry. Sorry. That was rude. Yes. I didn't move it. Right.